Good morning students, myself Sushmita, Assistant Professor, EC Department RCET. So in this session we will be seeing about antenna and microwave engineering, how amplifier design is being done. So on completing this video you will be able to explain the filter design by using image parameter method, also filter design by using insertion loss method, and you will be able to explain the power loss ratio. So first let me say an introduction. So filter is nothing but it is a two-port network. So we can use this particular two-port network to control the frequency response at a certain point in RF for microwave system. We can just provide the transmission at any frequency within the passband of the filter as well as the attenuation in the stop band of the filter. Applications can be found in virtually any type of RF or microwave communication as well as radar or test and measurement system. So these structures initially of interest in themselves because their application is slow wave components and traveling base amplifier design. All they exhibit is pass band, stop band responses, and this particular thing leads to a design in image parameter by using filter design. So basically we can use two methods for filter design. One is image parameter method and another one is insertion loss method. So first thing, image parameter method. So in image parameter method it will be having a cascade of simple two-port filter. So this will be providing the desired cutoff frequency that is need to pass as well as the attenuation characteristics which do not allow the specification of a particular frequency response over a complete operating range. So next thing is insertion loss method. So by using insertion loss method we can go for designing the filter within the specified frequency that we actually need. So this particular design is simplified by using low pass filter prototypes at the beginning, and they are normalized in terms of both impedance as well as frequency. So next one is filter design by the image parameter method. So image parameter method normally involves the specification of passband as well as stop band characteristics of a cascade two-port network. So in means other thing, this particular method is very simple, but it has a disadvantage that arbitrary frequency response cannot be incorporated into the design. So this in contrast is to the insertion loss method. So next thing is the image parameter method. It will be finding an application in solid state traveling wave amplifier design. So next one is filter design by using insertion loss method. So filter design using insertion loss method is applied if a perfect filter, that is it will be having zero insertion loss in the passband as well as it will be having infinite attenuation in the stop band and a linear phase response. So linear phase response in the sense it will not be having any signal distortion in the passband. So of course this particular signals do not exist in actual practice. So what we are going to do is, in order to compromise this, we are going to use the filter design. So by using this insertion loss method we can allow high degree of control over the passband and the stop band amplitude as well as the phase characteristics with the systematic way to synthesize a desired response. So coming to the power loss ratio, so we can calculate the insertion power loss method of a filter by defining its insertion loss or power loss ratio. So this particular thing is denoted as PLR, where PLR is equal to power available from the source divided by the power delivered to the load. So we can denote it as P incident divided by P load. So this is again expressed in terms of reflection coefficient, so which is given as 1 divided by 1 minus tau of omega whole square. So this is called as power loss ratio. So this is how it works. So now let me tell you some possible questions out of this topic. So first one is define power loss ratio, and second one is explain insertion loss ratio. I hope you all understood the session and had a useful session. Thank you.